What is the cost of safety? Safety is the number one concern of the nuclear industry, and it can be argued that no cost should be spared. Regular inspections are a cornerstone to this safety focus. However, current inspection methods can be outdated, slow, and unnecessarily expensive. During outages, pressure tubes are inspected to monitor the concentration of hydrogen and deuterium. Measuring this content allows us to check the health of pressure tubes, as this hydrogen and deuterium can cause the tubes to weaken and eventually lead to cracking. The current method of conducting these measurements does provide accurate results. However, it's time-consuming and expensive, costing roughly $5 million in preparation, execution, and analysis. Scrape methods require some amount of material to be taken from the inside of this irradiated environment, securely packaged and shipped off-site for analysis, exposing workers to irradiated samples. But there is a better way to do this. Using laser-induced breakdown spectroscopy, or LIBS, we can accurately measure the concentration of hydrogen for a fraction of the cost. This method works by ablating a small amount of material and observing the light emitted. From this light, we can calculate the hydrogen concentration. The amount of material required for this is much less than needed by scrape methods, meaning that there's a much lower chance of introducing a flaw. LIBS is a well-developed method which has been used in many different applications with many cited studies. These measurements can be made remotely, with optical fibers delivering and capturing the light and using remote control over the system. Operator interaction will be as simple as pressing a single button, and they receive easy, immediate results. This will drastically reduce the time associated with inspections and also eliminate the dose received by maintenance personnel. As a further enhancement to safety, workers would no longer be required to handle radioactive samples during inspections. With all of these factors considered, we expect that the cost of preparation and inspection analysis could be reduced to about $1.5 million. And we predict to fully develop this idea, it would take about $2 million over 3 years. However, to develop a proof of concept prototype, a large number of resources currently available at McMaster University are being leveraged, with the $25,000 being put towards various optical equipment. The team behind this project is myself, a Masters of Applied Science student, and my two supervisors, Professors Dave Novak and John Preston. The funding from this competition, coupled with a partnership with OPG, will help to push this idea forward and may prove to be the future of reactor inspections. The device we're developing greatly reduces the cost and time of performing pressure tube inspections while maintaining that required high degree of accuracy. It can quickly perform concentration measurements and requires no off-site analysis and eliminates the need to handle radioactive samples, reducing the cost of inspection campaigns by an estimated $3.5 million. Thank you.